Hello, and thanks for streaming The Near Futurist, a show presented by me, Guy Clapperton. This is a fortnightly look at the technologies that are going to affect our lives in, wait for it, the near future. Now, in this episode, we're looking at the Internet of Things, in which objects rather than computers become interconnected and offer each other information. A lot of that is going to depend on the 5G networks, and it's going to be vital for a lot of industries. But people do worry about whether their fridge is going to be telling the insurer about their dietary habits. Just me? Okay. To talk us through some of the issues is today's guest. He started several businesses in multiple industries, giving him a dynamic range of experience. His areas of expertise include device connectivity, IoT, that's Internet of Things, architectures, sensors, data collection and analyses, including AI and machine learning applications. He founded his current company 15 years ago after exiting his previous startup and works closely on Internet of Things architecture and design with his clients to achieve their desired outcomes. The company is Teracode and his name is Michael Sack. Mike, welcome.
Hi, Guy. It's a pleasure to be here.
Excellent. Okay, so look, at the risk of talking down to some of the listeners who will be specialists, but they won't all, the Internet of Things is a phrase I hear an awful lot, but not everybody understands it. A lot of them think it might be about their Amazon device spying on them or something like that. Could you give us an idea of what's actually possible and why it should matter to us in our daily lives?
Sure, and I think people have a good reason to be concerned because part of the Internet of Things is connecting everything around us that's really not human to the internet, and even things that are human, things like the watches we wear, our phones, all collect data today, and that data can be used for a variety of purposes. Some of it bad, and some of it, most of it, for the good. And I'd like to focus on the good because I think that's what drives us to adopt this technology. It will be the technology that helps us understand our health, understand our safety, understand our needs, help us be better consumers, help us be better citizens of planet Earth. It's very big, right? It's not something that's as simple as the Amazon device spying on them. It really is about, being able to be more efficient in your manufacturing processes, a better driver, to be prompted to eat healthier, so that you can live longer.
Okay, people are, of course, entitled to be concerned about privacy, and you did just mention that. I used the flippant example of your fridge reporting back to your doctor or whoever, your insurer, about food in the intro. But what would you say to people who are seriously concerned about their privacy? How much of this can they control?
So I think the real secret to Internet of Things is that we don't need to know who you are to be able to help you. When we can collect data from refrigerators in mass and understand what's in them and what people are buying, we can give that information back to the industries that make food, so that they can understand what types of things sit in refrigerators and get used in refrigerators. It can also be useful to consumers to be able to access data for them to understand healthy choices, but also to understand, the availability of different products and so forth. We have a client that has products that go to waste because they don't sell fast enough on the store shelves. So it's close to the refrigerator. But what we're helping them do is understand where their products actually sell, the rates at which they sell, so that they can manufacture the right amount of product, deliver it to the right stores, and reduce waste in their pipeline.
That sounds to me just a lot like decent stock control rather than anything particularly technological.
Well, you're right to some degree, but it really comes from the data. And today, I think we mix terminology. Internet of Things is really about connecting devices to the internet and getting data from them remotely and being able to manage them remotely. So, a connected refrigerator is a refrigerator where when you're, on vacation, you can look on your phone and see what the temperature is and know that it's working, it's on, et cetera, et cetera. The Internet of Things combined with artificial intelligence and machine learning is a refrigerator that we can track its performance and its temperature and actually predict if it's going to have a failure and lose its ability to keep the food in your refrigerator cold. And even while you're away on vacation, could trigger a message that goes to a technician who can, come and fix your refrigerator so it never breaks down. And combining the data that we get from the Internet of Things with machine learning is really what the future is about.
Okay, now I'm interested in this notion of data. I've spoken to a number of people on this show, in fact, about ethics, artificial intelligence, that sort of thing, big data. Is there really any such thing as completely objective data? I mean, taking my example about the fridge, and I don't want to get hung up on fridges here, but if I ran out of cheese, it could tell the supermarket there's an opportunity to sell me some more cheese. It could tell my dietitian, if I had one, that the fat swine's eating too much cheese again. It could tell someone gathering data on diets using me as a statistic. I'm just wondering whether data really exists in a purely objective way, or is it all about the interpretation?
So, I mean, I think you're raising a very interesting question and one that data scientists struggle with. As mathematicians and scientists, we like to believe that data is objective. But, the truth is, to your point, how it's collected, what data is chosen to be collected, the rate at which it's collected, what data we choose to ignore, all creates bias. So there is some amount of that. I think the best we can hope for is to try and be as objective as possible. In your example of your fridge spying on you, I mean, there's very little value at the end of the day in a fridge spying on you because you probably don't live alone and other people are using products. And unless we have cameras, and no one's going to let you have a camera take pictures of you pulling cheese out of your refrigerator anytime soon anyway, at least in the Western hemisphere. We really don't know who's using the products. We just know what the refrigerator is doing. And what we're really interested in today from an industrial standpoint and from a health standpoint is, if you want to choose to share data with your care team so that they can help you be healthier, you have the ability to do it. You have, we don't recall what we ate yesterday for breakfast. We don't know what we took out of the refrigerator last Tuesday. If that's being tracked and we want to share it, and at our choice, our discretion, share it with somebody who can help us make better eating decisions, better food purchasing decisions to live longer and be healthier, then it should be our choice. And technology to enable that will help us do that in an easier way. So I'm a proponent from that perspective. Do I think the refrigerator should chastise you because you've taken too much cheese out of it? No, I don't think that adds value. And I don't think people will like that. And they'll ultimately reject that technology.
That all sounds like a lot of good sense. It sounds very interesting, but much as it's going to upset you and the rest of the listeners, I'm going to stop talking about fridges now because I think I may have run dry on that one. But I
The
am aware
topics
that
are
you're doing
cold.
something. I'm aware you're doing something really interesting in India on a rather different scale. So I wonder if you could tell me a bit about the Ganges.
Sure. So as many people know, the Ganges is a very large river system in India. It has many tributaries and other bodies of water feeding into it. It is the largest supply of water in India. It starts in the Himalayas and it runs almost through the entire country, and it's very polluted. Right. I think what most people would think of when they think of the Ganges River is pollution, and they're not wrong. It's a concern because it's a threat to human life in India, and it will have great implications for health, for the economy, and for the stability of the country. The government, along with many people in the private sector, are heavily invested in helping figure out how to clean it up. And that starts with understanding the health of the river, being able to monitor it across its journey, the water across its long journey, to understand where the pollution is occurring, what the pollution consists of, so that we have a basic, platform on which to understand the health of the river. From there, we now can make changes and interdictions to try and improve the quality of water. So our platform, our technology, what we're helping the government of India do is uh, establish that baseline set of metrics and then give them the ability to analyze different technologies, different tools that they're employing to clean river water, and tell them if it works, and give them predictive models about its ability to scale and what it will cost, so that decisions can be made about how to invest in the future of the river.
That's a very, very detailed answer. I'd like to pick it apart a little, if I may. I know that an awful lot of people actually bathe in the Ganges. It's a well-known tradition. I believe in certain areas it's part of their faith, but I could be getting that completely wrong because I'm not an expert. Can you give me an idea of the scale of the problem? How many people are actually affected by the pollution in the Ganges?
So yes, people do bathe in it, but wastewater is deposited into the Ganges River as well, and the number one pollutant in the water is biological waste. There's also chemical waste that comes from factories along the river. When you look at the entire river basin, you're approaching roughly half the population of the country of India that's affected, and it's at today over 1.3 billion. So you're talking about millions, hundreds of millions of people who are affected by the Ganges River.
That is astonishing as an amount of people. I mean, I'm in a country where, we think getting to 64 million people was quite a lot. It's obviously not in that on that scale. The other thing is, of course, I know nothing about cleaning rivers. What I'm just wondering what sort of data points you look for, and how you actually managed to engage with the Indian government. To what extent your company had to become expert in rivers rather than just in data collection.
So, we partner closely with the Indian government and the India Institute of Technology, particularly with a division from Kanpur that a doctor, uh, uh, Vinod Tare, is the leader of the project for the Clean Ganges River. And they provide the expertise on the river, right? They're experts on that. Our job is to be experts on data collection, measurement, data display, and predictive modeling, so that they can pose questions and we can help them find the answers to those questions. It's a tremendous thing to be, knowledgeable about what affects a river. It's all comes down to, though, parts per million of a particular substance in water that's measured. So when you're talking about biological waste, we want to know how much biological waste is in the water, what level is safe. Being below that level is critical. When we're talking about toxins and chemical poisons, what level is safe, how do we get below that number? And then we look at biological life, because that's another indicator of river health. Are there fish? Are they swimming in the river? Are they breeding? Are there more than there were last year? All of those kinds of metrics tell us what the status of the river is. But in total, we're looking at over 150 different data points measured from 8 to 10 different locations on the river. And we're monitoring as many as 20 to 30 different technologies being used to clean water and to see if it has an impact.
So, how do you collect this data? Are we talking sensors? Are we talking cameras? Are we talking supercomputer? Or is it a whole mix? I'm really interested in what actually goes into making a project like this work.
Well, so this is still a hard part of the project. A lot of the data collection is still manual. So there are still people who are, um, going to specific locations and collecting water samples multiple times a day, testing the water and recording those measurements. Part of the project over the long term is to find ways to automate that. So to have automated sensors that can do the data collection, and even to use technologies like satellites. There's a company out of Eastern Europe that takes pictures of the river, and that gives us the ability to understand conditions in the water by parsing the pictures, and using deep learning algorithms and convolutional neural networks to assess the changes that we can detect.
Right. So that's I've not heard the phrase convolutional neural network. Could you just elaborate that, please?
Sure. It's teaching a computer how to understand what a picture is probably the simplest way to explain it. So I can teach a computer to recognize a picture of, let's say a rose. And if I keep showing it the same picture of a rose or something that's very close to that picture, it's fairly easy for the computer to understand that. But as you and I both know, there are millions of different ways in which a rose could be presented. And teaching a computer to recognize a rose, even when it doesn't present itself the way it did in the original training photos, is what a convolutional neural network does. It breaks every bit of a rose down into a pattern. It stores that pattern. And then when it sees a new picture, it does the same thing. It breaks it down into a pattern. And if it matches, if we find enough matches, we have the ability for the computer to identify something. And so those types of networks give us the power to, to use pictures that could come from satellites to actually understand if the quality of water is improving or declining by looking at pictures of from the satellites.
Okay, and if we can move away from the technology a little, I mean, which sounds fascinating in its own right, but there must be a point at which acting on the data becomes a political or financial decision rather than something that's purely, data driven. You could say you can fix this river by spending $50 billion a day on it, and that's frankly just not going to happen. Is there a role for the data gatherer or for companies like yours in there at all, or are you really just there to present the data and then allow the decision makers to make the big decisions?
So, you're touching on probably the single greatest challenge that we're all going to face in the new era of data, where politics and money and society intersect with what data tells us. Um, right at this stage, the politics are complex. There is pressure to, obviously, um, to bring technologies to bear that will clean the river, that will help make the water usable for farming, for drinking, for sustainability, for economics. But there are also real costs to doing it, and the money has to come from somewhere. So everything's a balancing act. Our job is to give the politicians and policymakers the tools and a view of the data from which to make the best possible decisions given the circumstances they find themselves in. Will they always make the right decisions? As we know, politicians don't always do that. They try their best. We hope they try their best,
I'm
and that's
sure
what
most
we're
of them
counting
do.
on. But we're giving them more than they had before, right?
Yeah.
We're giving them a chance to do a better job with the decision making with tools like this.
And would it be stretching it too far to suggest that one of the things you're trying to do, and I don't want to commit you to saying that you're actually achieving this just yet, but perhaps one of your endeavors is to, using modeling, almost give them the benefit of hindsight in advance?
That's absolutely correct. So what we're trying to do, in fact, modeling is more like forecasting. So we all kind of joke about what job do you get to be wrong half the time and keep it? Weather forecaster. Um, the forecasting the weather has actually become much more accurate than it was even 20 or 30 years ago using modeling techniques. And I like the word forecasting. Nate Silver, who's famous for the use of the word forecasting, teaches this. The idea is to give you a range of probabilities. If you take decision path A, there's a 90% probability this will happen. If you take decision path B, there's a 60% probability that will happen. It just gives you a range of choices. So it's not black or white. A lot of times when we make decisions, we think it's an either or. And we want people to understand that it's never really an either or. It's always shades of gray. And so our tool is really designed to show people the probability of taking a certain path and the ramifications of making a different choice, and letting them weigh the probabilities and making the measured guess.
Okay, now I'm going to ask a question which may not be entirely fair in many ways. Having caveated it with that, I'm just wondering whether you have any inclination, any instinct, or indeed any data on how quickly you can accelerate progress in programs that are designed to save lives. Because I'm assuming this data on the Ganges is partly feeding into existing projects to help them with their decisions. I'm just wondering whether you've been able to accelerate those projects.
I mean, at this stage, I would say we probably haven't because we're still primarily focused on the health of the river and having a really good system in place to understand the health, be able to predict what's going to happen to the river based on what we see coming, based on weather forecasts, based on seasonal changes. But at the same time, we're sharing our data with other people. So other projects that leverage this data can be benefiting from it. We just haven't, been able to stop and catch our breath and group and, regroup with those teams to understand to what extent they're benefiting. We expect once the platform is more widely available, many more projects will be looking to gather and use this data in their own research and for their own purposes. So we think it's going to grow from where we are today quite substantially.
Okay, that's obviously a huge project, really interesting. I'm just wondering what other areas you're involved in.
On this particular project or just sort of in general?
In general, I mean, Ganges, that's obviously a massive project, but I'm
Oh
assuming
yeah,
there's
I
a
mean,
whole wealth of them.
so we touch on so many different things. We do work in the medical device industry. We help companies that make medical devices that are used for surgical procedures know when their devices are going to break down ahead of time. So you don't go in for eye surgery only to find out, hey, sorry, the device is broken. We're going to have to reschedule for 7 weeks. We can actually predict when those devices will need service a week ahead of time. So we can actually schedule technicians in a very timely way to make sure that the machines stay up and running. We monitor refrigeration units to make sure that they stay within temperature ranges. We can predict when the cooling system is failing or going to fail, so we can get a technician there before produce or meat is wasted in a cooler and a refrigerator and inside a supermarket. We work with energy companies to monitor boilers to make sure that they're operating safely. We work with paper towel companies that put the paper towels into the bathrooms where when you're traveling through an airport. Remember those days when we used to travel, and most importantly, in this past year, we've helped them monitor hand sanitizer stations to make sure that they never run empty. Because what good is a hand sanitizer station if it's out of hand sanitizer? So we can send messages to the custodial teams and let them know that they need to go replace the bags or the bottles that are inside the sanitizers. And the list of projects goes on. I mean, we've helped restaurants implement food ordering and tracking systems. We've helped companies build wearables that can monitor your health. We work with major pharmaceutical companies, helping them automate documentation processes. It's I love this because it's not just one thing, right? It's so many different problems to solve, and they all come back to collecting data, figuring out how to get that data in the most cost-effective way, and then using math and science to do something positive with it.
It really does sound fascinating, but we are running out of time now, so perhaps I could ask you finally how listeners can find out more about you and what you do.
Sure, we'd love to answer anybody's questions. We're at www.teracode.com. That's TERACODE.com. And you can reach out to us through our website, and we'll be happy to tell you about IoT, answer questions. We have a special audit that we do for people who are already doing IoT, just to sort of help them understand if it's on track, how it could be improved. We provide that free of charge to people. So that's a service your audience could take advantage of.
Michael Sack, founder and chief executive of Teracode, thank you very much for joining me.
Guy, it was an absolute pleasure. Thank you so much.
And of course, many thanks to you for listening. That was the Near Futurist podcast with me, Guy Clapperton. Don't forget to have a look at the website at nearfuturist.co.uk or my media training site at remotemediatraining.com. I'll be back in 2 weeks' time. Stopping the recording now.